Hi, welcome to our next Foundations of Computer Science class. Today we are going to be looking at an overview of software systems, and then we're going to look at computer performance and start the first part of our computer buying project. So I'm going to navigate to modules. You can navigate to our weekly view for this course material. So in modules, we are looking at our software lesson now. And I'm going to open up the slides. Let's look at our brain activators for our odd day. So if you are in my third period class, this is time for you to go ahead and press pause and try to get these brain activators. And if you are in my even day class, it's time for you to press pause and see if you can get these brain activators. All right, so now that you've had time to pause and try the brain activators, this first one, a lot of times we're looking for something over something or something in something. This would be objection overruled, and that would be a court terminology when one of the two parties in court objects to a statement. The judge has the ability to rule in favor of the objection or rule against the objection. And when you have an objection overruled, that means you're going to continue on with your original line of questioning that your objection did not meet merit to cast out that information. This middle one, we've got some Y's, and we have a guy, wise guy. And a lot of times you'll hear the term, oh, well, he's a wise guy or she's a wise guy, as somebody who is kind of making some snarky comments. And then this last one is beady little eyes. Beady little eyes. And that is a look that you may say somebody has when they're looking at something with malice or bad intent. Beady little eyes. Looking at our even day or our 6 period answers. First one that we have is a cross reference. And the second thing is a detached retina. And that's something that can happen with your eye. The retina can actually detach. And then this last one is at ease or at ease, E-A-S-E. And it's a saying in the military when your squadron or your flight is no longer standing at attention. Standing at ease is a little bit more relaxed stance. So again, today we are looking at software, and then we're going to continue on with our first part of computer buying. So if I look at our software homepage, again, I'm coming from the module view, and I click software. Our overview for today is we have a warm-up, which we'll see on our slides. We're taking notes. We have a quick assessment, and we're going to continue on to the first part of computer buying. If you are in class, I will give you a copy of the warm-up in a Google Chat link. Otherwise, you can come to our software page and make a copy of this. So for the warm-up today, you're going to make a copy of this presentation and then slot over these pictures to determine whether or not you think they are hardware or software. So just a drag and drop type thing. So go ahead and press pause and try that. All right, continuing on, we should see that anything that is a anything that we covered in the previous class, like the mouse, the disk drive, the speakers, the modem, the monitor, the hard drive, keyboard, printer, are all considered hardware. software, Excel, PowerPoint, Word. Google Chrome is software. Windows 10 is an operating system, which is also software. Windows Movie Maker is also software. So within our digital systems, which we've been covering the past couple of classes, we've got both hardware and software. And as a refresher, a digital system is a system that operates in two states, on, off, or yes, no, or binary ones and zeros. Let's watch a quick video about hardware and software.
Hardware and software, two terms you've probably heard of at one point or another. The odds are high that you use both on a daily basis, whether it's with your smartphone or personal.
Little technical difficulty there, so let my computer continue going. I need to press start again.
Personal computer.
And now go to
Let's take a deeper look at what these two things are and why they're important. Hardware is any element of a computer that's physical. This includes things like monitors, keyboards, and also the insides of devices like microchips and hard drives. Software is anything that tells hardware what to do and how to do it, including computer programs and apps on your phone. So video games, photo editors, and web browsers are just a few examples. Hardware and software are very different from each other, but they also need one another in order to function. Let's look at an example of this using a smartphone. In this case, the hardware would be the physical phone itself, and the software would be its operating system and its apps. If we were to take away the software, we would just have a dead phone in our hands. It wouldn't be able to make calls, text, or go online because it's not receiving any kind of instructions. On the other hand, let's say we have no hardware, meaning there's no actual phone. If all we have are the programs, we just have a bunch of instructions, but nothing to give those instructions to. So the big picture here is that hardware needs software to tell it what to do, but software also needs hardware in order to act out its directions. Technology will continue to evolve, and though we may not be sure of how things will look in, say, 100 years, this combination of hardware and software will be there, serving as its foundation.
GCF Global.
Okay.
Creating opportunities for a better life.
Moving on, we're going to look a little bit more about software today, but our overall big picture is we can't operate hardware or software without each other. We need both to make our computer systems work. Official definition, software is the programming that tells the hardware components what to do. So our processor, our CPU, is going to send out instructions, and the software is those instructions that the CPU uses to help make those decisions on your computer. We have some different types of software. We can have operating system software, and this manages the overall operation of the computer. How does the computer interact with the user? And that is through your operating system software. So the operating system software loads automatically, and it controls the hardware and software. It allows you to manage your files. And again, it's that intermediary between the computer and you. So we can usually find the operating system information in the settings on our computer. If you're on a Windows-based computer, if you click the Windows button and go to settings, you can go into your computer control to figure out what type of operating system you're on. One type of operating system is a Mac-based operating system, and that's for any Apple product. Another operating system is a Windows operating system, and there's different versions of that. You can have a Windows XP, you can have Windows 10, and these occasionally will update. We can have a Linux-based system or a Unix-based system, and these are often favored by people that like pure computer science because it's an open source software. You can make changes to the system. And then we can have an MS-DOS based system. And we could notice that this is not visual based, it's just text based. It has no graphic user interface, no GUI. Application software performs specific tasks. Do I want to do my taxes? Do I want to watch a movie? Do I want to play a game? That's all a specific task. You can't operate the application software without an operating system. And these types of software are written for a specific type of operating system. Most of the times now, we will download this software from the internet. In the past, you used to have to go to a store and buy a package. And with either situation, you do need to make sure you are installing the correct version for your system. We saw this term GUI before. The graphical user interface is going to vary based upon the operating system you have. And this is just how do the icons look on your computer? What do the graphics look like? It's a visual component for us to be able to use that software. So we have some pictures of some different graphical interfaces. What I want you to do is go through and figure out what type of system you're running. If you're on a Windows-based system or at our computer lab at school, you are going to hit the Windows button. And when you do that, you're going to go to your settings. You may have to scroll to that. You should be able to just search settings as well. And let's see if I can pull this up here. I've opened up the settings and I want to go to my system. And then I'm going to go to About, and it's going to give information about my system. So we can see I'm running a laptop and I have an AMD processor. I have 8 gigabytes of RAM and I have about 6 gigabytes usable. I've got my device and product ID. I can see what type of system that I'm on. I have a 64-bit operating system, and scroll down a little bit. I'm running Windows. I have a Windows-based operating system, Windows 10. So I do want you to go ahead and press pause and see if you can find out what type of system you have. Exit task for today. It's a quick assessment. I will post this link in our chat, but if you are not here for our chat, what you can do is come to our homepage and either scroll down to the week at a glance or go into modules. And in our software, there is a hardware versus software assessment. It's going to open up a form for you. And you're going to fill out this assessment for me. And it'll give us an idea of where you're at for hardware versus software. So go ahead and press pause to complete that. I'll give the class about 5 minutes. And again, you need to press pause, and then we're going to move on to our computer buying. So let's look at our computer buying. The first thing I want to do is recap what makes a computer a computer.
My name is Mei Ku, and I'm a designer and an inventor. So some of the things I've designed have been at Apple, and now I design products for kids to use so that they can have an easier time in school. My other jobs include DJing and dancing. Computers are everywhere. They're in people's pockets, they're in people's cars, people have them on their wrists, they might be in your backpack right now. But what makes a computer a computer?
What does make a computer anyway?
And how does it even work?
Hi, I'm Nat. I was one of the original designers of the Xbox. I've been working with computers since I was maybe 7 years old, and now I work on virtual reality. As humans, we've always built tools to help us solve problems. Tools like a wheelbarrow, a hammer, or a printing press, or a tractor trailer. All of these inventions helped us with manual work. Over time, people began to wonder if a machine could be designed and built to help us with the thinking work we do, like solving equations or tracking the stars in the sky. Rather than moving or manipulating physical things like dirt and stone, these machines would need to be designed to manipulate information.
As the pioneers of computer science explored how to design a thinking machine, they realized that it had to perform 4 different tasks. It would need to take input, store information, process it, and then output the results. Now, this might sound simple, but these 4 things are common to all computers. That's what makes a computer a computer.
The earliest computers were made out of wood and metal with mechanical levers and gears. By the 20th century, though, computers started using electrical components. These early computers were really large and really slow. A computer the size of a room might take hours just to do a basic math problem.
These machines are things of gleaming, vari-colored metal and numerous flashing lights.
Computers started out as basic calculators, which was already really awesome at the time, and they were only manipulating numbers back then. But now we can use them to talk to each other, we can use them to play games, control robots, and do any crazy thing that you could probably imagine.
Modern computers look nothing like those clunky old machines, but they still do these same 4 things.
First, we're going to talk about input. This is my favorite because what input is the stuff that the world does or that you do that makes the computer do stuff. You can tell a computer what to do with the keyboard, you can tell them what to do with the mouse, the microphone, the camera, and now if you're wearing a computer on your wrist, it might listen to your heartbeat, or in your car, it might be listening to what the car is doing, and a touch screen can actually sense your finger, and it takes that as input on what it's doing.
All these different inputs give a computer information which is then stored in memory. A computer's processor takes information from memory, it manipulates it or changes it using an algorithm, which is just a series of commands, and then it sends the processed information back to be stored in memory again. This continues until the processed information is ready to be output. How a computer outputs information depends on what the computer is designed to do. A computer display can show text, photos, videos, or interactive games, even virtual reality. The output of a computer may even include signals to control a robot. And when computers connect over the internet, the output from one computer becomes the input to another, and vice versa.
The computers we use today look really different from the earliest thinking machines. And who knows what the computers of tomorrow will be like. My hope is that you get to help decide what you want the computers of tomorrow to look like. But across all computers, regardless of the different types of technology they use, they're always doing the same 4 things. They take in information, they store it as data, they process it, and then they output the results.
All right, so this gives us a really great overview of what we've been studying in what makes a computer a computer. And we've studied now the components of the computer. We have a little bit more that we need to look at, and we're going to look at some computer performance aspects, starting to think about if we were to buy a computer, what might we need to think about when buying a computer? So one of the things we want to think about is the CPU speed, and that is how fast can that CPU handle the instructions that are coming to it. We want to think about the amount of RAM, how much or how many different processes can we have open at the same time. And that speed of the CPU is going to come into play as well, because the CPU is going to be sending the messages out to those different processes. The hard disk capacity depends upon how much we need to download and store permanently on our computer. When we're looking at speeds, we've got some average speeds, but we can also go onto our settings and our system properties to figure out what the speed of our computer is. In general, you want to get the fastest processor that you can afford. That's one of the key aspects you want to look for, the fastest processor that you can afford. You also need to think about the operating system software. Do you prefer a Windows-based system? Do you prefer a Mac-based system? Do you want to configure the system on your own and have a Linux-based system? So we just copied that today. Again, the operating system is what's going to load automatically when you start your computer, and it's going to vary based upon the manufacturer of your computer. Again, you can go into your system properties to figure that out. So with computer buying, I want you to complete an MCPS discussion. This is going to end us for today. We've had a chance to look at the definition of a computer and how the computer solves problems. We've seen many different types of computers. I want you to go to our discussion and think of a problem that a computer can help you solve. What's the problem? What information is input into the computer? What information does the computer store? What information does the computer process? What information does the computer output? Now, this isn't necessarily an arithmetic problem, but it could also be something like, how do I get from my house to the grocery store? Or what's the best route to bike? Or how can I order a package? Or how can I order groceries? So computers can help you with a lot of different problems. So think about something that a computer helps you with and go through that process. If you need to find the discussion online, you can go into discussions, or you can go to our week at a glance, or you can go to module view, and under software, computer buying, we have this discussion that I will actually post in here so you can have it in there. This one may be it. No, it's not. So I will post it in here so we have that. So give me a second. I'm going to press pause and I will put it in there. All right, so now looking in module view, I have added this discussion, how do computers help? And we also have one more short tasking, which is another quick assessment on what makes a computer a computer. After watching that video, can you come up with what makes a computer a computer? And that wraps up our lesson for today. Next class, we're going to finish the computer buying process, watch a couple more videos, and learn about our assignment. Hope you have a great day, and I'll see you next class.